Welcome. Today, let's explore the complex landscape of inequalities together. Join me.
So what I want us to do today is to look at how to plot a graph of inequalities. Okay, so I will show you the best way to plot your graph. Okay, the quickest method uh, for graph of inequality. All right. So you remember that equation of a straight line can be written in this form: y equals mx plus c, where m is the gradient and c is the intercept on y-axis. Okay, all right, intercept on y-axis. So you can use the same thing for your inequality. Okay, so in this case, y greater than or equal to mx plus c. Okay, whether y greater than or equal to or y less than or equal to, okay, or y less than or y greater than. Okay, so what this has done for us, what we want to achieve with this, is to know the region that satisfies the inequality. But there are two processes involved here. One is to get the boundary point, the boundary line. Okay, so let's quickly look at that. For example, if we're given y greater than or equal to say, all right, I'm going to change that because that does not it works actually, but I want something a bit that is not straightforward. Maybe we have y, okay, plus say 2x greater than or equal to 14, for example. Okay, so the first thing you want to do is to find the boundary point so as to draw the boundary line. How do you do that? Forget about the inequality sign first and introduce equal to, make it like an equation. All right, so you then have y equals 14 minus 2x. Okay, y equals minus 2x plus 14. In that case, we have made it look like what we have up here. Can you see that? All right, so now you now say when x equals 0, what will be the value of y? If we insert x equals 0 here, definitely your y becomes 14. So we have gotten the very first point for our boundary, that is when x equals 0 and y equals 15. We do the same thing when y equals 0. That equation becomes 0 equals minus 2x plus 14. So in this case now you make x the subject of the formula, then x becomes 14 divided by 2, which is equal to 7. All right, now we have the second point, which is now what? Our x is 7. Don't forget, you always write x first. Our x is 7 and y equals 0. All right, so this has given us our boundary point. So you go to your graph. Okay, we have the y-axis and we have the x-axis and the y-axis. You label it accordingly, the positive and negative. You see that the highest value here on the y-axis is 14. So let me use a scale of 2 centimeters to represent 2 units. So 2, 4, 6, 8, 10, 12, and let's say 14 is 0. Then we have 0 here. We have negative 2. We label it also. Then on the x-axis, the highest number there is positive 7. So I can use 2 centimeters to represent 1 unit. Okay, so I do that up to 7. It does not necessarily mean we must stop at the highest number, but then what you want to ensure is that the highest number is captured in your graph. Okay, so having gotten our points for the boundary line, so the first thing you want to do is to plot the point 0 to 14, from 0 here on x-axis to 14 here. So our 14 is here. You mark that point, and the second point 7 to 0, which is this point 7 to 0. Okay, now you look at your sign, the sign we have in the question given us. You can see that this is greater than or equal to. Okay, so that is going to be a thick line across the point. Okay, it's a thick line. So let me quickly say something about, so when you have greater than or less than, you have dashed lines, that is broken lines, dashed lines. So the boundary is going to be a dashed line. But if you have greater than or equal to or less than or equal to, the line is going to be thick. So your boundary line is going to be thick. So that's why we have this here. Now, to use this first method, so which is number 2 thing to draw our graph now. Number 1, I said, is to get the boundary line. We have done that. Number 2 is to get the region that satisfies the inequality. How do we do that? There are several, there are 2 methods. Okay, this is the first one. And look at the question given to us initially. It was y plus 2x greater than or equal to y plus 2x greater than or equal to 14, right? So in this method, your target is to make sure that the inequality becomes like this. And by that, I mean y is standing alone and is also positive. Okay, take note, it must be positive. So it becomes greater than or equal to 14 minus 2x. All right, so since it's greater than, it is the region above the boundary line that satisfies the inequality. So if we are shading the region that satisfies the inequality, everything above this line is, so this line instead that we have drawn is line y equals minus 2x plus 14. Okay, that's the line. So region that satisfies it, when it's greater than, it's above. When it is less than, it's below. Okay, when it is greater than, whether greater than or equal to, it is above. When it is less than or equal to or less than, it is below. All right, the only difference between greater than and greater than equal to is the boundary line. In greater than or equal to, the boundary line is included. That's why it's thick. In greater than alone, the boundary line is not included. Okay, the same thing with less than and less than equal to. I hope you understand this method. What have we done? We try to get the boundary line by getting the point which line the line passes through. Okay, we got the point, we plot the graph. If it is greater than or equal to, it's going to be a thick line. If it is greater than or just less than, it's going to be a broken line. And when you make it in form of y equals mx plus c, the region above, when it's greater than, satisfies the inequality, while the region below, when it is less than, satisfies the inequality. I will come your way again. Just enjoy this and let me know what you feel in the comment section. Thank you.